Welcome back, everybody. Today's lesson is on mapping. I said mapping, not napping, so please make sure you stay awake during this. What mapping is trying to figure out how do we get a figure to land on top of another figure based off of different transformations. Now, the key to mapping is that we want all of our points to line up exactly where they're supposed to, and we want to try to do the fewest transformations that we can. We're going to start off with a really easy example. This one's nice because it actually tells us where we need to go from step 1 to step 2. If you notice, here's our starting points. What they ask us to do is they want us to make this shape land so that A becomes A prime, B becomes B prime, and C becomes C prime. So what we would like to do is think about what kind of different transformations can make that happen. So let's go through the list. First, reflections. If we were to reflect this particular shape over an axis, if we reflected it over the y-axis, it would bring us into the correct quadrant. However, sure, C might line up, but look what happens to B. If we reflect over the y-axis, B ends up in the wrong place, and we know that this thing's going to be pointing up instead of to the side. So a reflection's probably no good. Translation, same idea. Translation just means that we're moving the shape. So if we move it over, it's still going to be pointing up, which is no good. We want a rotation. We want this thing so that it's pointing a different way. Hopefully we can see that if we start here, we only need to go 90 degrees in order to make it line up. We can check that real quick. Maybe we'll take a test point, maybe even 2. I'm going to just do A and C, because if A and C work, then B is probably going to just fall into place. So real quick, A is located at -6,2, and C is located at -2,2. And I'm just going to check to see if they land where we want them. If I put it through a 90-degree rotation, that's going to give me y and the opposite of x, which is +6. C would end up at 2 and the opposite of -2, which is +2. So C prime fell at 2,2, good there. A prime was at 2,6, good there. And I bet you if we were to test B, we would see that it lands where we want it. So we have our first. Right? So we're going to make sure that we mention that. First, rotate 90 degrees. Then, well, we got to figure out what to do next. Well, hopefully we notice that we're not going to rotate again from this image to this image, right? It's pointing the same direction, so we don't want it to point down, which is what would happen if we rotated. We're going to have to either translate or reflect. Well, let's check out the translate option. Translating just shifts the whole object down. But notice how here I have A prime above C prime, and down here C prime is on top of A prime. So if I was to slide this down, A does not line up where it should in this figure. So a translation, probably not the best idea. What we might want to try looking at is a reflection. And I'm seeing that this is the line I would want to reflect across, so I'm just going to check. It's C happens to be 2 units away from our line of reflection, and C double prime ends up being the same distance. A is 6 units away, and if I count 6 units away, that's where A double prime lives. B prime was 4 units, B double prime is 4 units on the other side. So I just checked to make sure that I have the correct transformation, and we do. We want to make sure that we reflect over the x-axis. That's the mapping that brings ABC to A prime, B prime, C prime, down to A double prime, B double prime, C double prime. That's all mapping is. It's just going backwards. So here's our next example. If you want to take a second to try this one on your own, pause the video, try it on your own, see if you can come up with a mapping, and then resume the video and we'll go over it together. So this is how we do this problem. We're going to look. Here's our figure, LMN. LMN we could very easily do a reflection and another reflection. If we reflected, that would bring L over here, and if we do another reflection, it would bring L down here. And we would see the same thing with M, and then M being far away, N, and then N being closer. We could do the double reflection. However, if you remember from the beginning of this video, I said that we want the fewest number of transformations possible, especially seeing as this tells us that there's only one transformation that's needed. So we've got to think about it for a minute. What transformation would make this object face another direction and end up in a whole different quadrant? Translations are just going to slide it. So translation's not going to work. This figure would be pointing the wrong way. And we said that if we do a reflection, it's going to end up doing a double reflection. Well, what about if we reflected over the line y equals x? We could try that. Here's the problem, though. I know that when I start reflecting over the line y equals x, that this shape is going to end up kind of where it was before. It's just going to end up in the wrong place. I can see that this bump is going to end up pointing out over here, and N is going to be down here. So it's no good. Actually, N would end up here, but M's in the wrong place if we reflect it. So we don't want to do a reflection over that line either. So what's the only other option left would be rotations. Now I'm checking out my rotation. If I go 90, it would end up in this quadrant. No good. If I try 180, hey, we land in the right place, but let's just test to make sure that the points are where we want them to go. I'm especially looking at this point M. M is the one that we want to make sure really lines up. So maybe I'll test this side right here. So I'm going to test M's coordinate and N's coordinate, and if I get those right, most likely L will fall into place. So real quick, M, we notice, is at -3, 6, and L, we notice, is at -6, +6. And if we use a 180-degree rotation, that tells us switch the signs on x and y. So -3 becomes positive, +6 becomes negative. L prime, we end up with 6, -6. So let's just check. Do they land where we wanted them to? M3, -6. Hey, that's M prime. L6, -6. That's L prime. I bet you if we were to test -3, +3 would become +3, -3, +3, -3. Even N falls where we want it to. So all we need to do is tell our answer. We would say rotate 180 degrees, and that's the mapping that puts that figure onto its image. Compound transformations and mapping are very similar. The only difference is that we're going backwards with mapping, and we could be using multiple transformations or sometimes only one. But the important thing to keep in mind is that we're trying to find the fewest number of transformations that bring us from our pre-image to our image. I hope that helped.